Hi guys, I'm Joelle and I'm super excited to be celebrating CSEdWeek with all of you guys. So today we will be drawing some holiday shapes using recursion. What exactly is recursion? Well, recursion is the idea of repeating smaller steps until you get to the end or a base case. If you're still curious about what recursion is, make sure to keep watching because we will be drawing some fun shapes using recursion. So for our first shape, we will be drawing a Christmas tree. So over here on my canvas, it is blank, but it has some colorful lights in it. So when I click, I have one layer of my Christmas tree drawn. And if I click again, my second layer of my Christmas tree gets drawn. So notice how each layer gets smaller and smaller each time I click. This is a great example of recursion because it's doing the same thing over and over, but each time it's doing it, it's getting smaller and smaller. So let's go over to the code to see how this works. So first I have import random, and this generates the random spots of my lights because each time I click run, the lights show up in a different location. And I'll click to grow my Christmas tree a couple times. So, to start off, I first make a group for my tree, and then my base case will be that the level is 1. So that means when I only have one level left to draw, then that means I will stop. So in my first function, I have add lights, which has a list of colors that my lights can be. So over here I have red, magenta, yellow, purple, white, pink, and orange. And notice how on the canvas how all of these lights are reflected, but that's kind of random. So we loop through 25 times and draw 25 lights on each side. And you can tell they're just circles. So we have our circle call right here. So that is our add lights function, which creates all the lights on the side for our Christmas tree. Now for the actual Christmas tree part, we have a function called drawTree, and it takes in an X and a Y size and depth. So X and Y is where it's going to be centered. And then the size is how big the Christmas tree is going to be. And the depth is which layer are we on right now. So over here, this is checking for a base case. If depth equals 0, then we're going to return. That means we've drawn all the layers we need to because we have no more layers to draw. So that is going to be our base case when depth is 0, so we're going to return. Now to draw the actual tree, you guys can see that they're kind of just triangles, so we're going to use our polygon shape and draw at X and Y, which is our center, which is going to be like the top middle coordinate. And then our next coordinate is going to be our left coordinate, and we decrement it by the size and increase the y by size times 1.2. And then the other side, we have x plus size and y plus size times 1.2. These increments are to make the tree balanced and have the right shape. And of course, since it's a Christmas tree, it's going to be green. So once we have our triangle drawn, we're going to add it to our tree group with tree.add of t. So now we've drawn one triangle. So our new size for our next triangle will be smaller. So each of these triangles or layers, they are related to each other because they are 80% of the size of the previous triangle. So that means each time we go up the tree, our size decreases by 20%, which is why we have our new size to be our size times 0.8. So then this is where the recursion happens. We're going to call drawTree inside of drawTree. But instead of passing in the same arguments, x, y, size, and depth, we're going to pass in the same x, and then our y is going to be a little bit smaller because our tree layer is going to be up a little more. And then our new size, because we want our tree layers to be smaller, and our depth to be -1, because we need to keep track of how many layers we need to be drawing. So each time we call drawTree, we're going to keep decrementing the depth by 1 each time until we get 0. So if we pass in drawTree with a depth of 7, it will call itself 7 times before it returns, which means our tree has 7 layers. And this update tree function basically just clears out the entire tree every time you keep on mouse press, so that when we click, it will recursively draw each time. So in my on mouse press, I call update tree, which updates my entire tree to have the new layers that I need and increments my tree's level by 1 each time. And in update tree, this is where we make the call to drawTree, which is recursive. So we pass in our depth, which is tree.level, and in on mouse press, we're incrementing tree.level plus 1 each time. So we can run it and see how it works again. So on my first click, I have one layer and my tree dot level will be 1. And then on my second click, we're going to have 2 layers of my trees. And they keep getting smaller, which means we know the recursion is working. So I hope you guys enjoyed this recursive Christmas tree demo.
So the next shape we'll be drawing is a snowflake. The way that it works is that every single time you press a key, you draw more and more of the snowflake. I'm going to be sort of skipping over some stuff that's less important to understand, and really get into the recursion aspect of it pretty quickly. So we start with a snowflake group and give it a property, which is its level, and we initialize that equal to 1. So we start with a level 1 snowflake, which is, as you can see, what we just six lines. Just to skip to the bottom real quick, we see that on key press, as long as the snowflake level is less than 5, it's incremented by 1 each time you press, and then you update the snowflake. But to start, you start with initial update snowflake call. So what this update snowflake does, this function does, is that it clears the snowflake group, and then it draws 6 main branches, as you can see, and a center circle. And this is where the center circle is. So for the 6 main branches, each of them happen at an angle, sort of incrementing by 60 each time to make a full 360. And then there's a call to draw branch that takes in this angle and the snowflake level. So let's start with level 1, and let's just say an angle of 60. So we'll start with this, what should draw this line. So when we call draw branch, this is really the recursive function, and this is the base case. But we'll get into that later later in this code. So you calculate a new endpoint using some trig, and then you draw this main branch. It's just a line, fill white, line width 3, and you add that to the snowflake group. Then you want to draw smaller branches, like I said before. You saw those smaller branches, but you don't want to do that for the first level, right? So when you create this new length and you're making these next 2 calls to draw a branch, you're doing depth minus 1. So initially the depth was 1, since we called it on snowflake level of 1. So then when we were calling draw branch with a depth of 0, it's just going to return. So that's what it initially does. When the snowflake level is equal to 1, it just draws these 6 branches. Now, when we press a key, you need to update the snowflake again. So what that does is the snowflake is cleared. Again, there's a center circle. And then you draw 6 main branches of the snowflake. This time with the snowflake level of 2. Again, let's just take the angle of 60, which would be this one. And then what this does is, again, it calculates a new endpoint, and it draws a main branch, which would just be this one. It adds that branch to the group, and then it tries to create these next smaller branches, these little nubs at the end. So the new length is just 0.4 of the original length, and then you're making these 2 new calls to draw a branch. So this end x and end y is really just the endpoint that we calculated before. The new length is just 0.4 of the original length, and then there's an angle plus 60 and an angle minus 60. That's sort of just the part that's going over here and the snowflake part that's going over here. And then you're calling it on depth minus 1. So that means when you're making a call to this initial one, this angle plus 60, depth minus 1, that means that you're going to make a call back here, and this time the depth is going to be 1. So a new endpoint is calculated with some trig, and then you draw the main branch. So this right here would draw this one in our current trace, right? And add that to the group. And then if we try to call smaller branches for this little branch, it wouldn't work because depth minus 1 would be equal to 0, and then it would return. So really the way that this is working is that it's drawing six main branches, and then for each level, it's drawing another three at each of the branches, and so on and so forth.
So for our next shape, we're going to be drawing a recursive gingerbread man pattern. So first thing we're going to start off is by defining our function, which is called draw gingerbread man, and it's going to take in four parameters, which is the location of the gingerbread man, size, and the depth. So the way this is going to work in the end is we're going to call it with some recursive depth number, and every time we call the function recursively, we're basically going to decrement that depth. So like any good recursive function, we want to have a base case. The base case will basically tell us when we want the program to stop drawing our gingerbread man. So we know we're going to decrement the depth. So at some point it'll reach 0, and at that point we want to stop drawing the gingerbread man. So the first thing that we want to do in this function is set up some variables that we can use to draw the gingerbread man in proportion. So this is for the arm, leg, eye, and button parts of the gingerbread man. And these numbers are basically just chosen through trial and error of drawing the gingerbread man, just to make sure everything is in proportion. So now that we have these variables set up, we can start drawing our gingerbread man. So the first thing we want to do is draw our body. And to do that, we're going to draw one rectangle in the middle of our screen. And the way we're going to do that is we're going to use the x coordinate of our gingerbread man minus the size divided by 2. And for the y coordinate, we're going to basically do the same thing. And we want the height and width of this to both be size. So when we draw that, we get a nice little rectangle here that we can start off with. Next, we want to draw a circle right here to give the torso some shape. And to do that, we're going to use a circle. So we're going to use the x coordinate that we have here, and we want to use the y coordinate to be y plus half of the size of this. So that will put our y coordinate right about here. Remember that adding something to the y coordinate will basically move it down in the canvas. And we want the radius of this circle to be half of this square that we've created. So that's size divided by 2. So if we run this, we get a nice little circle down here attached to our rectangle. Next, we want to draw the head of our gingerbread man. So to do this, we're going to use the same x coordinate here. And for the y coordinate, we're going to basically use y minus the size of this rectangle, and minus the size again. So if we just write it with y minus the size, we'll basically get a circle here. But we want to make sure that there's a little more space for the arms, so we're going to move that up by subtracting size times 0.3 as well. So now that we've moved that circle up, this is what it looks like, and we have a little more room to draw the arms of the gingerbread man as well. So for the arms, we're going to use one rectangle that goes across this way. So to do that, we're going to use the same x coordinate that we start off with minus 1 arm's width. And for the y coordinate, we're going to use this arm y position that we have defined up here, minus 1 half of the arm's width. And for the height and width of this, we're basically going to use 2 times the arm's length so that the width or the length of the rectangle will go all the way across for both arms. And we're going to use the arm width that we have defined up here. So once we run that, we can get this nice little rectangle for both the arms. Next, we want to draw a circle for the hands. So basically, we want to draw one circle here and one circle right here. So to do that, we're going to draw the left hand first. We're going to use the x coordinate minus 1 arm's length. So we get the x coordinate to be along here. And for the y coordinate, we're going to use the arm y position that we defined up here. And we want the radius of this to be half of this arm width. So if we run that, we get one circle right there. We're going to do the same for the other side, but instead of decreasing the arm length, we're going to add it to the other side instead. That way we can have this x coordinate plus the arm's length, which will put us right here. So if we run that, we can get a nice little hand for the other side as well. Next, we want to draw the legs of the gingerbread man. So to do that, we want to draw one circle here and one circle right here. So we're going to start off with the x coordinate again, and we're going to subtract one leg size. So that'll put us from here to here. And for our y coordinate, we're going to use the leg y position that we have defined up here. And the radius of this is going to be the size of the leg. So that is the size times 0.4, which we have defined up here. And if we run that, we can get one nice circle here. We're going to do the same for the other leg. And instead, again, we're going to add the leg size instead of subtracting it, just as we did with the hands. And if we run this, we get one leg for the right as well. So now that we have our basic shape of our gingerbread man, we want to add some eyes and add some buttons so we can give him some life. So to do that, we're going to basically draw two circles, one with a slightly bigger radius, which will be white, and then one with half of that radius, which will be black. So for the white part of the eye, we're going to start off with the x coordinate and subtract this ix offset, which we have defined up here, as well as the y coordinate being the iy offset, and we're going to use the eye radius to draw the white part of the eye. So if we run that, we get one white circle here. And we're going to use the same position for the x and y, and instead use half of the radius to draw the black part. So once we run that, we can get one iris of the eye for the left. We're going to do the same thing for the other side, but instead of using x minus the ix offset, we're going to use plus so that we can move to the right this time instead. So if we want to see the white part first, we can get that. And do the same thing with half of the eye radius, and we can get both of its eyes. Finally, we're going to draw the buttons of our gingerbread man. So we have our button size and button Y offset defined up here. So the first one that we're going to draw is with the same X coordinate. And for the Y coordinate, we're going to use the Y position that we started off with minus the Y button offset. So once we run that, we get one button up here. For the middle button, we're not going to offset the Y coordinate by anything, just so it stays right at the position that we want our gingerbread man to be. So it'll be at the center of its torso. So we use our same X and Y coordinates and the button size to get that middle button. And finally, for the last button, we're going to add the Y offset so it's positioned just a little bit lower. So if we run that, we basically have our first gingerbread man shape. Now, we want to call this recursively to draw multiple gingerbread men. So to do that, we basically have to define the new size that we want our subsequent gingerbread man to be. In this case, we want it to be half of the size, and we basically want to position one gingerbread man here and one on this side. And so basically, they're just kind of shooting out of each other on either shoulder. So to do that, we have the new size to be defined as half of the original size of the gingerbread man, and we have these two variables defined for the vertical and horizontal offset of the gingerbread man. So for the vertical offset, we basically want it to be the size times 2.5. So it'll be positioned right about here for the vertical offset. And for the horizontal offset, we're going to be using the same multiplier of 2.5, but we're going to be using the arm's length instead. So it'll be positioned right about here. Now we can call our function recursively. So to do that, we're basically just going to call the same function that we have defined up here. So we're going to be using draw gingerbread man, and we want to pass in these 4 parameters. Our 4 parameters are going to be the position of the gingerbread man, so the X and Y position, the new size, and then the depth decremented. So our new X coordinate is going to be X minus the horizontal offset. Our new Y coordinate is going to be Y minus the vertical offset. Our new size is going to be half of the original size, and the recursive depth will be decremented by 1. So if we just run that, we'll basically be able to draw gingerbread men just on one side, which will be the X minus the horizontal offset side. So if we run that, we can see gingerbread men going this way. And if we call that again recursively for the other shoulder as well, we would just be adding X plus the horizontal offset. And if we run that, we can give him a buddy on either side. Finally, I have this on-step function so that we can add a little more animation and really bring this picture to life. But in this, we're basically calling our first recursive call, which is the draw gingerbread man function. For the coordinates of this, we're going to be using half of the canvas. So we're positioned on the x-coordinate right in the center. And for the y-coordinate, we're dividing it by 1.5, so we're just a little bit lower than half. For the initial size, we're going to be using 50, and we're going to be using a recursive depth of 3, so we get 3 layers of gingerbread men, 1, 2, and 3. Finally, we can also draw some snowflakes just to really bring this to life. If you want to take a look at the code, it is up here. And if we run that, we basically get our final picture of our gingerbread men.
All right, well, on to our next topic. What we're going to be drawing now is recursive presents. So the first thing we're going to look at is our canvas. Notice how I've added a tree, some snow, some lights, a star, and a trunk. Kind of give the Christmas or the holiday feel. So to look at this background, notice how there's a bunch of white dots just constantly flowing down the screen. When we look at that, we can see that I've written around line 6, 7, 8, and 9 a for loop that ranges about 150. And through each iteration, I draw a circle on a random point in the canvas. So I use this rand range 400 that gives the random number between 0 and 399. And I'm able to use this little function here because I imported the random at the top. And once we loop through all of those, we can see that there's a bunch of circles around the screen, kind of gives the illusion of snow. The next thing you can see is I draw a tree. This tree is actually a one single polygon centered at this point, 200, 300. It's a series of triangles that is constantly pointing back up to 200, 300, giving the illusion of a tree. And then after that, I proceeded to draw some lights. They're essentially a certain number of lights that kind of fit within the range of the tree, and they all have around the same slope to kind of give a little consistent feel of Christmas lights on the tree. And at the top of the tree, I drew a star. I also drew a trunk at the bottom. But the biggest thing of the background is the on step. So under the on step function, I loop through each circle that is present on the screen. So at every iteration or every step, I loop through every single circle. And then as I'm looping through each circle, I see where is its center X, or where is its center Y, I mean. So if its center Y is past the bottom of the canvas, so if it's greater than or equal to 400, I send it all the way back up to the top. And then after that, I simply add 3 to the snow's Y position. This kind of gives the illusion of falling snowfall consistently, kind of gives a nice homey background. But let's get to the meat of the problem. So today we're going to be drawing presents recursively. So notice how under on mouse press, I draw a present using this draw present helper function. The parameters it intakes is mouse X, mouse Y, and user parameters. So I want to start my first present to have a width and a height of 50, and the recursive part, I have the depth set to 1. So what this does is every time I click, I draw a present where with the width and height of 50, but since I have a depth of 1, I only draw 1 present. All right, so let's get into the recursive part of the code. So I have a list of colors that I've set to kind of create a random color for each present. And whenever you're using recursion, remember you have a base case. So in this case, if our depth is equal to 0, that means we've hit the floor for all of our presents that we want to draw, and we don't want to draw anymore. We want to exit the function. So if our depth is equal to 0, we go ahead and return. If not, that means we still have to draw a present. So in this case, we take the width and the height and the X and the Y that is entered in the draw present parameters, and we draw a rectangle. So we draw our rectangle with X minus width over 2. This kind of gets the present to be centered each time it's drawn, because remember the presents or rectangles are drawn in the top left corner. And then I fill it with a random color of rand range 6 through these colors in the colors list, and then I give it a border of white. To spice it up, I add a little bit of a ribbon. So I add 2 rectangles, one going horizontally where I start at the X position, I move it over by 1/2 of the width, and then I decrease the height just ever so slightly by 20 to kind of give it this this position in the center. And I have the width is the same since it crosses the entire screen, but in this case, I have the height is divided by 10. This way the rectangle is very thin and it gives the illusion of a ribbon. I'll do the same thing for the vertical ribbon and I move on. And here's another important part. So when we go through the recursion, what we want to do is we want to decrease the size of the presence. So let's say I use 3 presents or 3 as my depth for my presents. So in this case, when I run, notice how I have a big present, then I have 2 smaller presents, then I have 2 even smaller presents next to those smaller presents. So what we want to do is after each recursive call, we want to calculate a new width and a new height. This way we can decrease the size of the present, kind of give it the an appeal of a bunch of small and big presents kind of piled up, kind of what they would look like under a tree. So in this case, I decrease my width and my height to around 60%, where I multiply width and height by 0.6. And I set my new left, X left, and my new X right equal to my width times 0.75, whether or not I minus or subtract it. So for the X left, I subtract my width and my multiply by 0.75 to kind of push this present right here where my cursor is. I push it just past the present, the larger present to the left, and I keep it kind of touching to kind of keep them all clumped up together. And the next thing I do is I create a new Y. So I create a new center point where I decrease the Y value down by adding a 1/4 of the height. So as you can see, a 1/4 of this rectangle, if I added center from here, a 1/4 of it will go down to around here, which would be the center of this second biggest present. And the most important part of this is a recursive call. So in this case, since we draw 2 presents to the side of one big present at each time, we want to have 2 recursive calls at the end of the function. So in this case, we draw a present and we use the new X left coordinate. So this gives the left side of the presents, and we have our new Y, our new width, our new height, and our depth -1. So we subtract our depth -1 because we've exhausted this index of the depth. So we've used this depth layer. So at this point, we want to decrease the depth by 1. And so hopefully we get to 0 and we exit the function. The next thing we do is we draw the same present, but the only thing we change is our new X right. So in this case, it draws a present to the left, present to the right. And then with those 2 presents, it draws another present to the left, another present to the right. So to walk through this recursion, I draw 1 big present, and then I draw 2 small presents. And then with each of those 2 small presents, I do another set of 2 recursive calls, or recursive call for both new X left and new X right, where I draw 2 more smaller present, one on the right, and then one on the left. And then I do the same thing for the other present, and so on and so forth for the larger numbers. I hope that helped. You guys are having a great holidays, and I wish you guys the best.
Thanks for watching, and I hope you guys have a great rest of your CS Ed week.